Hey everybody, it's Mrs. Mancuso, and today we are going to go over calorimetry and do some more practice. So to get started here, when we're talking about calorimetry, we're talking about heat. And so if you go to table T, you will get all of your heat formulas. Those are all of the Q formulas. So Q equals MHF, Q equals MHV, and Q equals MC delta T. And you're going to figure out which one to use based on what they tell you in the problem. So this first one, what is the number of joules of heat needed to melt 65 grams of ice? So if I'm melting, I want Q equals MHF because melting is heat of fusion. That first plateau on our heating curve is fusion. So the mass is 65. And now I go look up the heat of fusion on the reference tables, and it tells me that for water, the heat of fusion is 334. So now I'm punching into my calculator, 65 times 334, and I get 21710 joules. All right, next problem. How much heat must be added to completely boil? So if I'm boiling, my formula is Q equals MHV. I need the heat of vaporization. And it's water, so I'm going to look that value up. 45.5 is the mass, and then I look up heat of vaporization on the front of my reference tables, 2260. And I multiply those. 45.5 times 2260. I get 102,830 joules. All right, moving right along here. And so for every problem, I expect you to do exactly what I'm doing. Write out the formula, write out like showing your work, and then solve it. And make sure you always use units for heat. All right, you have 130 grams of water. How much heat is required to raise the temperature? Okay, if I'm raising the temperature, I want Q is equal to MC delta T. So my mass is 130. The specific heat of water is 4.18. Again, that's on the front of the reference tables. And then I'm changing the temperature. I'm going from 10 to 90. So 10 to 90, I'm changing it 80 degrees. All right, I'm punching into the calculator. 130 times 4.18 times 80. And I get 43,472 joules. All right, next one. It requires 3,500 joules to change the temperature of a sample from 30 to 60. How many grams are there? So this time I'm going to solve for M, and I'm changing the temperature. So I want Q equals MC delta T. This is my Q, so 3,500 joules is how much it needs. M is my X. That's what I'm going to solve for. They're asking me to find the mass. C is 4.18. And I'm changing it from 30 to 60. That's a change of 30 degrees. So the first thing I'm going to do is multiply 4.18 times 30. That gives me 125.4. I'm going to divide both sides by 125.4. That will make this cancel out. So M is going to be equal to 3,500 divided by 125.4. And I get 27.9. And that unit would be grams. All right, next one here. What is the heat of fusion? So if they're asking me for heat of fusion, I need to do Q equals MHF because I'm going to have to solve for HF. That's going to be my unknown. All right, my Q is 50,200 joules. My mass is 35, and I got to find HF. So I'm going to divide this side by 35 and divide this side by 35. These will cancel out. HF is going to equal, all right, I'm punching into the calculator, 50,200 divided by 35. I get 1434.3. All right, next one. 64,000 joules was required to melt a 40-gram sample. What's the heat of fusion? So again, they want me to find HF, so Q equals MHF. Q is 64,000. The mass is 40. So I'm going to divide both sides by 40. These will cancel out. HF is going to equal 64,000 divided by 40 is equal to 1,600. Okay. In case you're looking at this and wondering what the unit is, this was joules and this was grams, so it's joules per gram. This one would also be joules per gram. All right, next one. 3,950 joules are added to 40-gram sample of water at 25 degrees. What is the final temperature? Okay, so I know the temperature is going to change, so I need Q equals MC delta T. This is 3950. My mass is 40. Specific heat of water is 4.18. And then delta T is what I'm solving for. So the first thing I'm going to do is punch into my calculator 40 times 4.18. And I get 167.2. So I'm going to divide both sides by 167.2. That lets me cancel this out. And now delta T would be equal to 3950 divided by 167.2. Punch that into my calculator and I get 23.6. But I'm not done. I'm not done. That tells me the change in temperature, but the final temperature is going to be, all right, it started at 25. So 25 plus this change in temperature is going to give me 48.6 degrees Celsius. That's going to be the final temperature. Don't forget, and just give me the change in temperature. You got to give me the final temperature. All right, what is the heat of vaporization? So they want me to solve for HV. So my formula has to be Q equals MHV. And it required 430,200 joules equals 75 HV. Divide this side by 75, divide this side by 75. These will cancel out. HV is going to equal 430,200 divided by 75 equals, I get 5,736. Again, this was joules, this is grams, so my units would be joules per gram. Down to the next one. Again, if I'm going too fast, just slow down, pause me, do the problem yourself, and then see if you get the same answer as me. All right, 105 kilojoules. Ooh, kilojoules. That's 105,000 joules. I have to put 3 more zeros onto the end of it. I got to move the decimal 3 places to the right to change it from kilojoules to joules. All right, it was required to melt. All right, Q equals M, HF is melting. What is the heat of fusion? Okay, so if I know the mass is 25, I want to find HF. So divide this side by 25. Divide this side by 25. These will cancel out. HF is going to equal 105,000 divided by 25 equals 4,200 joules per gram. Now, if you solved it the other way and you kept it in kilojoules, it would have came out 4.2 kilojoules per gram. But you got to make sure you show that in your units, okay? All right, 6,720 joules were added to a 50-gram sample of water at 15 degrees. Oh, what's the final temperature? So again, one of these Q equals MC delta T's. So 6720 is equal to 50 times 4.18 times delta T. So I'm going to multiply 50 times 4.18. That gives me 209. So I'm going to divide both sides by 209. So delta T is going to equal 6720 divided by 209. That gives me 32.2. But that's just the change in temperature. It started at 15. So I got to go plus 15. So that's 47.2 degrees Celsius would be the final temperature of the water. All right, next one. What's the number of joules of heat needed to melt? All right, if I'm melting, I want Q equals MHF, the heat of fusion. The mass is 350 grams and heat of fusion is 334. So I just multiply 350 times 334 and I get 116,900 joules. A lot of heat to melt that much ice. All right, how much heat must be needed to completely boil? All right, Q equals mHV if I'm boiling. So the mass is 230. Boiling it is 2260. This is going to be an even bigger number. 230 times 2260 is equal to 519,000. Oops. Where'd my screen go? 519,800 joules. All right. Ooh, we are on to our last problem. You have 450 grams of water at 10 degrees. How much is required to raise the temperature to 40 degrees? So I want Q equals MC delta T because I got to change temperature. I have 450 grams of water. Specific heat of water is 4.18, and I'm changing from 10 to 40. So that's a change of 30 degrees. So 450 times 4.18 times 30 is equal to 56,430 joules. All right, I hope that that helped you, and good luck with the rest of your problems. Make sure you go through the pre-quiz, and I'll make another video for the pre-quiz before you take your quiz. Bye.